Okay, hello. I think we are live. I really hope we're live anyway. let's uh let's get going. Hello there. Oh my goodness, I am low in this chair today. Give me 1 second, I just remembered. Need to turn the lights on so I can actually be seen. It helps a lot if you can actually be seen. I hope that good. I hope this microphone will play along and will stay where I've put it, otherwise we're not going to have very much in the way of sound. Okay, that's not what I wanted. Everything has gone wrong today, isn't it? Oh my goodness. Right. So, welcome back to episode 6 of GameHammer Live Game Coding, where we are doing a text adventure on the Amstrad CPC. Let's bring the Amstrad up. So, this week, last week I stopped the stream a little early because there wasn't time to do a logic puzzle that I wanted to put into the game. So what we're going to do is start with that logic puzzle. Now I've worked it out. I spent a while working it out today. I'm just going to put my phone somewhere. And what I've got is this. This is a lot of physics, basic physics, but still physics. We've got a circuit diagram, and the logic puzzle is going to involve, I don't know why Java CPC is crackling a lot, but there we go. We're doing a logic puzzle with a lot of resistors. The idea is that the ship, when it crashed, or during the time it crashed, the resistors burst and popped out of one of the circuits. So the arbiter, our character, is going to need to replace them, basically. So luckily there will be a place in the storage room that we just opened on the last episode, where there's a box of resistors, spare ones, and of course the arbiter by that point will be holding the multi-tool, or should have them access to the multi-tool, which will mean that she can sort them out. So, with that in mind, let's get into it. Oh, hello, Anthony. All is good. Hi, Anthony says hi. Hope all is good. Yes, all is good. So let's get into the game. Where are we? Let's bring the computer back up. Bling bling. I just did this as a little fun piece. Right. Control Shift Escape. We'll give it the 3-finger salute. Catalog. Episode 1 is what we need. Load episode 1. It's 21k. My goodness. That's a lot of K now. Remember, we only have about 48 to play with, so yeah, let's do this. And oh, Patrick says things have gone well today. Got to see his baby niece. That's nice, Patrick. Excellent. Okay, so we need to go into the game code, and I've made, as you can see at the top of the listing here, I've made it a bit bigger. Let's put it that way. A bit different at the top. I've changed the arrangement of last week because of some issues. We had to put the dimensions and set up stuff right at the start of the program. Well, I've changed it around now while I was getting set up. So the copyright information is straight at the front of the program, and then the setup information, and then and anything that says go to line 10 will just take us straight to the title screen. So that makes it an awful lot better and easier to sort things out. It also means I know exactly where I need to be if I need to change any information. So, right. You have put me in the mood to make a Spectrum game, says Anthony. I would love to see what you do with that, Anthony. That would be great. So, I'm just thinking, before we start moving on, we will need to add in some extra information into the code, because the circuit diagram, we need to know, we need to have the option of actually we don't need to put any new information in. Now there's an interesting point. We'll need to create some objects, but we don't need to create any new flags or any new holders because we can use the position of things to determine what's in which location. So, going back to the circuit diagram that I've got here, which I'll put into the game, you'll be able to see it. I'm going to set, we've got 3 sockets that need stuff in it. We have socket A, socket B, and socket C, which is what they'll be called in the game, I think. So, if I use the inventory system that we've got and say, let's say -10 is for socket A, -11 is for socket B, and -12 is for socket C, then we don't need to add in any new flags. We can just use the inventory system that we've already got to say, okay, anything that's in inventory point -10 is in socket A. And we can do checks from that using the object position or objpos variable that we've already got. So that means we don't have to change the load and save code. We don't have to change the initial setup of arrays. We don't need to take up any more of the CPC's memory, and we can still do the puzzle. So that is good news for us. So let's get into this. If I bring up the picture of the map, we can see that we need to look at the computer control room, room 4, and the cargo/storage bay, room 14. So we also need to set up an object. And we're going to need to set up object number 8 according to my list here, which is a cardboard box. So, we're also going to need 6 more objects after that because we will need 6 different resistors. The puzzle is going to be using the correct resistors in the correct order. So, let's do that. Let's have object 9, 10, 11, 12, 13, and 14. We need a set of resistors. So where have I got my list of resistors? Right, 1000, 1000, 1000. Okay. Oh dear. 552, 601, 407. One, 407. And I'm going to call all of these different things. So that's red, blue, green, yellow, pink, and orange. Just so that we can distinguish them all. So I now have a list of 7 objects that we need to put into the game. So we need to know where in the code the objects are. This is initial setup, guys. Sorry if it's a little bit dull for you. We'll get going in a moment. Right, so we need to know where are we. The game data is between 250 and 3000 according to my information. So if we go to list 200 to 3000, let's have a look at where the objects are that we need to sort out. Oh, it gets long, isn't it? It's an awful lot of information here on the screen because this is just the data. Okay, let's make a note of that at line 2000. That's where the exits data starts. So that we don't have to do this all the time and we can find it quicker. Objects data starts at 2500. I should have been making a note of this as we went along, but I didn't. Patrick says, information. Sensors detect good quality game coding from Zoe tonight. Patrick, I hope I do not disappoint. Sensors definitely detect a cold incoming for Zoe, so if I start sneezing and sniffing a lot, I do apologise. I'm sure over the barrier of the internet you will not pick up the virus that I've picked up. I spent the last, 6 months doing election campaigning, knocking on doors, talking to people. You pick up all kinds of bugs because, as you would when you're in an area with people that you don't really know, you pick up any germs that are going around. So I'm coming down with a cold. Sorry, guys. But I'm drinking lots of fluids to keep myself going. So let's have a look at the data we've got here. Keeps going down. And there we are. Okay. We need to put in 2,527 data. Okay, I've forgotten one thing. We need another thing for the inventory. The cardboard box will be at inventory point -9, just so that we know, so that we can put things in and out of the cardboard box, which you probably won't want to do, but in fact, probably definitely won't want to do, but we'll have it as an option. So we're going to put in 2527 data is cardboard box. Is that correct? Yes, we're going to call it box. A cardboard box. This was a small box made of cardboard. It was cardboard, likely designed to hold small items. Okay, that's in. 2528 data. Is it? No. Red resistor. No. A red 1000 ohm resistor. This was a small red with 1000 ohms marked on the side. 2529 data. Blue resistor, a blue 1000 ohm resistor. This was a small blue resistor with 1000 ohms marked on the side. We're just going to keep doing this because it's quick. 2530 data. This one is green resistor, a green 1000 ohm resistor. This was a small green resistor with 1000 ohms marked on the side, blah blah blah. 25 list 2500 to 3000. How are we getting on? This does seem okay, doesn't it? Yes. Yeah. 2531 data. Yellow resistor. Yellow. And this one isn't 1000 ohm, is it? This one is 552 ohm resistor. So this was a small, and then yellow resistor with 552 ohms marked on the side. 2532 data pink resistor. A pink, this one is 601 ohm resistor. This was a small pink resistor with 601 ohms marked on the side. 2533. Okay, where is that? Orange. Orange resistor, a small and an orange. This one's 407. Ohm resistor. This was a small orange resistor with 407 ohms marked on the side. Let me just take that out there. Okay, now we've got all of that in, we need to edit 2610 because that is the location of all of our objects. So we're going to say, according to the map, let's bring the map up here, the cargo and stash storage bay is room 14, and that's where we're going to put the box. But all of the things that are in the box, according to my notes, are going to be in room -9. So we need to add on to the end of this 14 and then 6 -9s. 2, 3, 4, 5, 6. There we are. So now we need to list between 1 and 10 to find out where the objects are set. How many objects have we got? Objects are 7 there. Hi, Cartsman. It's a bit late to the party, but involved in the party now. Welcome to the party. We need to go to line number 6 because objects is now 14. We've doubled the amount of objects. Okay, let's save the game there. Episode 1. Takes a bit of time now. And go to the drives and Java CPC and save. Oh, speaking of Java CPC, I have added Java CPC to my website. So from the GameHammer.co.uk website, you can now play games. So that's fun. Okay, let's run the game and make sure that the box is in position. Press S to start. Okay, syntax error in 2533. What's wrong with this? I don't know. Why is this one different to the rest? That's the last one as well. So what's wrong with that? List 2530 to 2533. There's always something wrong, isn't there? Okay. Oh, I see. That's why. Edit 2532. Got 2 commas there, which has upset the data statements. So save. Episode 1. And save it on there as well. But by having 2 commas in one of the lines, we'd upset the data, so it was reading extra information or reading information that wasn't suitable to fit into what was in there. So let's run that again and see how it goes. Press S to start. Okay, we're here. So if we load test, because that's the file, we should have done that from the title screen, but never mind. End of file met in 11250. Ooh. What's wrong with that? Oh, of course, we can't use the save file that we've got because we've added in extra objects, which messes everything up because now the data for the flags is being loaded into the object system. Whoops. Let's just start again and run. So we've got to go through the whole game from the start. That's not a problem, we can do this. So we need to go down, get multi-tool, get core, up, east, out, southwest, exam wreckage. Tells us all about the wreckage. Search wreckage. Found the crowbar, exam crowbar. All of the data for that works still. That's good. Go west. Nothing. We can now fix wire with multi-tool. Oh, use multi-tool on wires. Pad the wires. Go west again. Tool on wires. East. Use crowbar on hatch. So we can go down. Get junk. Drop junk. Put core in housing. Now the bulkheads are open. So now we should be able to go up, south, and east. And there is a cardboard box. If we examine the box, this was a small box made of cardboard, likely designed to hold small items. Hi there, JJXB 2004. So now we know that the box is there, but we can't see anything in the box because we need to change the code for the examine system. That's fair. That's easy enough. We can do that. So, the examine code starts at line 10,050, and the inventory code starts at 10,120. So we don't have an awful lot of space to work with, but let's list 10,050 to 1,120. Okay, we have the examine code, blah, 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 blah. Yeah. Okay, let's put in 101.05 if B string equals box or B string equals B string equals cardboard box. Then go to, we have a gap in our code from 4,230 to 10,000. So I'm going to send this to 9,000 because we need some space to sort out the code for looking in this box. Yeah. 9,000 rem. Cardboard box examine code. Okay, 9010. We want 10050 to 10100. Just want a quick code. Okay, 9010 if object position C% equals current room percent or object position C% equals -1, then pen 3 print. Now we don't want C%. I already know what we're talking about here. I already know that the object is 8. Comma 3 and go to 9020 else pen 3 print. I could not see the cardboard box. Go to 3180, isn't it? The what now code? I'm going to do an awful lot of... Yeah, 3180. So JGXB 2004 has been doing some reverse engineering stuff on some Sega PC ports for Windows 98. Now that sounds interesting. Right, what I've just done there is basically replicate in the code for examining the cardboard box the quick check to make sure that the box is in the location or in the inventory. So at that point we can now move on. If it's not there, then say I could not see the cardboard box, but if it is there, go to 9020. So for t equals 1 to what's the variable we've got? obj %, and we need let's say d equals 0, and that we'll find out what that's for in a moment. For t equals 1 to object position, if to object number, if obj pos % yes of t equals -9, because that's what we had the note saying. Yep, cardboard box is inventory position -9. Then d equals 1. And dx equals dx plus I'm having so much trouble finding the right keys at the moment. Dx equals dx plus object string t comma 2. Okay. Next, t. 9030. dy equals, leave that alone. Okay. If d equals 1, then print inside the box was plus dx. Go to 3180, else print there was nothing in the box. Go to 3180. Right, that should, in those 3 lines there, quickly run a check to see if the position of any object is -9. If the position of that is not -9, it means it's set as in the box, and then we'll add it to a list of items. If there's nothing in the box, then it'll say there is nothing in the box. But we need to do a quick check, don't we? Yes. 9025. If what was that code? Left string dx, comma 2 equals then dx equals right string dx, comma length of dx -2. Else. And then edit 9030, because we want to put one thing on the end of this, plus full stop. Right, save that. Save as episode 1. This is very quick code. I've just basically done a quick check to make sure that the start of the list of objects in the box does not start with a comma. And then I added a full stop at the end, just to make it look nice. It's all about presentation, isn't it? Right, run. Oh, we should have saved the game. We haven't changed. Yeah, we should have saved the game. Right, let's do this quickly and then save the game. Down. Get multi-tool. Get core. Up. East. Out. Southwest. I know how to play this game so easily now. Search wreckage. West. Use multi-tool on wires. West. West. Use multi-tool on wires. East. Use crowbar on hatch. Down. Get junk. Drop junk. Use core on housing. Save. Save file name as test. There we are. Save that as well on the Java CPC. Okay, go up, south, east, exam box. Type mismatch and oh, well, we're getting somewhere. This was a small box made of cardboard, likely designed to hold small items. This was a small box of cardboard, likely designed to hold small items. So, what we don't now know is, if we go to list 9,000 to 10,000, and we now know that we don't need the line 9010, because we've already got a check for that. Okay, 9010 we can just take out, and mismatch in 9025. Okay. Right, so that's a shame. I'd have thought that would have worked. It's basically just a check to make sure that the first... No, that's not it. Give me 1 second to find the manual. Right. 464 manual. So, alright, 1 second, I've just found out I've broken my microphone stand. Just going to quickly repair the foot on that, so that will probably make things sound an awful lot better once I've done that. Okay, that should stop any problems from vibrations. Sorry about that. Right, so we need to know what the type mismatch is. So it's in 9025, list 9025. So we need to look at the code for left string, which we've used before. It should have worked. Okay. Okay, if left string, so what's wrong with that? Print dx. Print dx is 0. Oh. Okay. Edit 9020. Well, we set up dx. Let's put dx string equals dx string plus. Yeah. Edit 9025. Hopefully that'll work. Edit 9030. Save that. Right. That should work. I would hope that would work now. I think it's just because we had it. We hadn't told the computer it was a string. How big is this program now? I bet we're 23K. That's getting big. We are definitely going to need a turbo loader for this. Okay, run. Where's my tissues? I also load a save game. The file name is test, which will be erased when we finish this, by the way. So I don't think you get a full save game. Up, south, east, exam, box. There was nothing in the box. Well, that's not true, is it? Because we know that there is something in the box. Oh, thank you. Yeah. Jen has turned up with a nice alcohol-free mixed fruit cider. Very nice.
How's it going?
It's going interestingly because it's not doing what I told it to, but it is kind of working. So, how are you doing?
I'm all right. Yeah, I just came in to have a nosy at what you're doing and give you your.
Oh, that is delicious.
I thought you might like that.
Right,
I'm going to leave you to it. Hello, everybody. Goodbye, everybody.
This is Jenny, by the way.
Yeah, I think some people may have met me before.
Oh, that is nice.
Yeah.
I'm starting to fall asleep. It's ridiculous. It's only 8 o'clock.
Really? Oh,
yeah.
I can't help you there.
I need my caffeine fix, man. I'm going to have to have a cup of tea later.
Okay, well, I'll let you get on. Bye-bye, everybody.
That is delicious. Thank you, babe. That's Jenny, everyone. She's my better half. Let's get back to the programming. So, what we've got here... everyone's saying hello, Jan. So, what we've got here is an interesting situation because apparently there is nothing in this cardboard box, even though we have told the game that things are in this cardboard box. Because if I print objpos % of, let's say, 14, it's at -9. So, let's list 9,000 to 10,000. There is the code. So, right. For t equals 1 to number of objects, if object position of t is equal to -9, then d equals 1, dx % equals dx % plus blah blah blah. Okay, my cat is attacking a plastic bag. That's what that noise is. So, get off, you little furry monster. Okay, if the object position equals -9, then it should be added to the list of objects, but it's not. So, is print D. D is set to 0, but it shouldn't be, should it? How many cats, Zoe, says JGXB. Only the one, my little Freddykins. I love her, she's great. But we have an issue here. Because if I print D, it's equal to 0. It shouldn't be equal to 0. It should be moving. It should be set to 1. So let's just try the same thing with the type mismatch we had earlier. D%. D% and edit 9030 D%, save episode 1, saved. It might just be that we didn't put that percentage in. Run, load, test. Oh, you got 4 cats. My goodness, I don't know if I could cope with 4 cats. One's enough, aren't you? Eh? Yeah, you are. She's a little furball, but I love her. Hello. Oh, you're lovely. Right, we need to go south, east, and have a look at this box. Actually, we're going to save at this point, because I don't want to have to keep going up, south, and east to just have a look at this thing. Okay, it's saved. Exam box. There was nothing in the box. Okay. Print D%. D% is still 0. So perhaps we're going about this the wrong way. Pen 3, so you can see it. List 9,000 to 10,000. This should work because it's basically the inventory code again. Edit 90. Actually, just rewrite 9020 entirely. 9020. For T equals 1. D% equals 1 to obj%. If obj% of T% equals -9, then dx% equals dx% plus, comma, plus object string. No, we can't have that, can we? Dx dollar. Otherwise it's not going to work because we'd have integers mixed with strings. T%, comma 2. Next, T. And then for 9030, dx string equals dx says less than or greater than nothing, then print inside the box was dx blah blah blah, else print there was nothing in the box. Edit 9020, dx string equals that. Yeah. Save episode. I don't know why I kept typing W at the start. Okay, now what I've done is basically just take a load of the code out that we don't need to. It was superfluous. It should work now, I'd hope, because we cut it back down to what we, excuse me, to what we just need for this thing. Load in the test. Exam box. Unexpected next in 9020. Edit 9020. Next T%. Okay, that's getting better. Load. Test. exam cardboard box. There was nothing in the box. Exam box. This was a small box made of cardboard, likely designed to hold small items. There was nothing in the box, but we know there is something in the box because we set all of the object positions earlier on to -9. We did set the object positions to -9, didn't we? List. Where is the objects data? It comes at 2,500 to 3,000. Yes, we did. All of those objects are in -9. So why doesn't it work? Let's have a look at the inventory code and see what happened there. List 10120. List 10120 to 10170. It's not a long code. Okay. For t equals 1 to number of objects. If object position of object t equals -1, so we should list it's the same code. Okay, 9010. We're going to do this the same way we've done it in this other code. T equals 1 to object position. 9020. If object position equals -1, then okay. And now we're going to change that -1 to -9. So if object position of t equals -9, then string L equals string L plus object t2. Next t. 9040. We take all of 9050. Right, very simple code. Edit 9050. But take all of the bit that I was carrying to the box contained else print. There was nothing in the box. We'll type that in. Okay, that's if this doesn't work, then I don't know what will. There was nothing in the box. If this doesn't work, then it means that there's something wrong with the detection code for where we've put those objects, which is a worrying matter in and of itself. Okay, save that, drive, blah blah blah. Okay, and run. So that should now work. L to load to save game. Test. This should work alright because we saved the game after we'd set the objects up, so they all should all be in the box. Exam box. Okay, well that's different. You can also see a cardboard box, a red 1000 ohm resistor. So, we've got an issue. But at least we're getting somewhere. So if I go to list 9000 to 10,000, edit 9010, that's preempt one thing that I think was wrong there. strl string equals blank, because we've already used it for something else. And 9040. Okay. Edit 9050. We don't need that pen 1 bit. Oh, I see what the problem is. Edit 9010. There we are. We needed to set it up correctly, so the if check was checking for something that we weren't telling it to do. So let's save that. I think we've got it now. Very simple code to get this to work once we know what we're doing. Load. Okay, exam box. The box contained a red 1000 ohm resistor, a blue 1000 ohm resistor, a green 1000 ohm resistor, a yellow 552 ohm resistor, a pink 601 ohm resistor, and an orange 407 ohm resistor. There we go. So, now we've got stuff there. But we have an issue. Because we can't get anything out of the box. And we need to make sure we can get stuff out of this box. So we need to alter the get code. And this is going to be an issue because it's a check for whether it's in... It's gonna be alright. Pen 3. We need to be able to check whether the box is in the ROM or in our inventory, and then check that the object we want to get is in the box. Yeah. So the get code is at 10,170 to 10,240, because that's when the drop code starts. Okay, if we put in 10229, my goodness, we are very close to running out of space. So, in order to get this in before we... No, actually. 10239 is going to be all of this. We need to move the get I could not see code to the absolute end of what the get code can be. 10230, move that out. Where are we up to? 10229. Go sub list 9,000 to 10,000. Fred, please stop attacking that bag. Okay, 10229, which is what we need to add in. Yes. Go sub at the end of this, which is 9070, because 9060. Fred, leave the bag alone. You're a little furry monster. Yes, you are. Leave the bag alone. You're making all kinds of noise on my little live stream. I'm trying to be professional here, little cat. and you keep attacking plastic bags. What's the matter, eh? I have a feeling I know what the matter is. Okay, guys. We'll be back in one moment. Let me just type this in. Extra get code. And I'll be back in just a moment. This is not normal for me. I need to go and feed the cat because she's going to keep attacking the bag if I don't. Come on, Fred. See you in a moment. Sorry about it, guys. I'll be back in a moment. You right, Jen? Okay. Thanks. The bottle of Coke, I'm ready to go. Thank you. I'm commandeering it. Sorry about that, guys, but I have found a bottle of Pepsi in the fridge, so I have commandeered it for the greater good. Okay. Sorry about that. Let's get back on. Right. We need the extra get code. So we've go soaked into this, so we've got to remember to do a return. 9070. So, if no, I can't remember what we do. Okay, I need to check the get code. 10170 to 10240. Just need to quickly look at it. Yeah. Okay. Right, I see. 9070. If object position percent C percent right, we need something else because okay. None of the code will work. None of the code for the get code will work. Okay. Let's do this then. B string equals yeah, it will. Okay, we can do this. If let's do this. D string equals right string B string length of B string now D string is right string B string 8 if D string equals from box and go to 9080 else return 9080 B string equals left string B string length of B string minus 8 okay 9090 if for t equals 1 to obj%. So basically what I've just done there is I need to make a check. I need to be able to say get something from box. And basically all I've done there is check the string that the player has inputted. We've cut off the bit that says get, so we've got this remaining, and it's called B string. I need to now check the last 8 characters of B string, if they're equal to from box, as in the player has typed get something from box, then we continue checking this code. If not, go back to where we were, and then it'll print an error message or whatever. So, now that we've got that, I need to just take the remainder of B string, as in the bit that isn't from box. And I've already done it wrong. Edit 9080, because we need to take off the remaining, we need to take off 9 characters because there'll be a space before from. So edit. So we've got that now. For t equals 1 to object number. If objpos percent of t, if the position of object equals -9, then obj no, we're doing it wrong. For t equals 1 to obj%. If upper string object, is it object? Just click my notes, check my notes. We did call it object string, didn't we? Yes, we did, object string. Object string t, 2 equals b% and objpos of t equals -9, then obj, that's not going to work because we need a percentage there, then pos percent t equals -1. Print I took plus, no, that won't work because the object there thing needs to be 1, not -2. I took object string t, 1 from the cardboard box, else no more 0, next t, return. Edit 9090. Print I did not see we don't need to do that bit because that's alright. And I'm getting a bit confused because the code has been put together over several weeks. Edit 9090. No, edit 910. What I was just putting in there was absolutely not necessary because what we were doing was adding in code to see whether an object was there and then move it into the inventory, and if it was, move it into the inventory. If it wasn't, put a piece of code, put a message on the screen saying that we couldn't find it. But of course, we already have that code saying I could not find X, Y, and Z, so I didn't need to add that in, so it made it less complex. But we do need to do one extra thing. Edit 9090 pen 3. Okay, save episode 1. Okay, what we should be able to do now is get something out of the box. We can't put anything back into the box. We'll do that code in a moment, but we should be okay for getting things out now. Load a saved game. Our name is test. Load it. Okay, exam box. Get red resistor from box. I took a cardboard box. No, we can't take the... I took a cardboard box. Of course you did. Why? 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 My cat's shouting for us. We're upstairs, Fred. You there? Hey there, Fred. Hello, you dafty. Did you not know where I'd gone? Hello? Oh, don't worry, baby. I'm just here. Buff. Right, you leave that plastic bag alone now, alright? Because you've been fed, so you're not getting fed again. Okay, okay, I've just said get red resistor. And instead of getting the red resistor, we took a cardboard box. That doesn't seem right to me. Drop box. I dropped the cardboard box. So, it's in the room. Exam box. We can see the resistors. Get black resistor. I took a cardboard box. Why? Why is it doing this to me? I don't understand what the problem is now. Is it something to do with the code that we just added? Shouldn't be. Let's check. We always have issues like this, don't we? 9,000... What was it? 9,060 or something like that? To 10,000. Yeah, the extra get code. We're looking at print B string. What's it actually say in the B string? Black resistor. That's all we wanted. So it does say black resistor. So run through the number of objects. If the name or code of the object, the thing that we type in to get it or drop it, is equal to what we've typed and the position of that object is -9, then put it into the inventory and print I took blah blah blah. I don't get it. Why are we taking the cardboard box? There's nothing in that code that would say cardboard box. So Why are we getting the cardboard box? It must be in the original get code. List 1017010240. Because it wasn't doing that before. We don't want to go sub because it'll come back and say I could not see X, Y, and Z if we do this correctly. Edit 10229. Go to 9070. List 9070 to 10,000. It's not return. Edit 9070. I'll score to 10239. Edit 9100. Okay, I think I've got it sorted now. So I need a quick check because I'm not sure why we need to add in all these checks. It's a weird situation that we've got where it's just picking up the box instead of the resistor, and I don't get it. But we'll keep going. So we're just putting in extra checks and balances and fiddling on with things. Okay, exam box. Get red resistor from box. I took a no, you didn't take a cardboard box. Took the cardboard box. Exam box. Get red from box. I was already holding. You weren't. Why is it picking up? Guys, any idea? Because this code worked until we start talking about resistors. Drop crowbar. Drop box. Get red resistor. Line does not exist in 10228. Two two eight. Okay, save episode 1. That was an easy fix because it's asking me to find something that isn't print the error message for if something isn't there. Oh. 10228210 240. There we are. Okay, I think I've solved it. I think we may have solved it. Save episode 1. Save. Because it wasn't doing the checks for that. It wasn't doing the checks for sorting this out. Okay, I think we may have solved it now, but we'll have to wait and see. Run. Load. Test. Exam box. So that. Get red resistor from box. I took a cardboard box. No, you didn't. No. You did not take the cardboard box. Get chimp. I was already holding. No, you weren't already holding. There is no chimp for you to be already holding. What is wrong? What is wrong with this thing? Apparently, we are now holding a chimp according to the game, even though there is no chimp in the game. Get... What else isn't... Get moon. I was already holding the moon. You weren't. There is no reason for this. Inventory. Holding a multi-tool, a crowbar and a cardboard box. Why does it think we're trying to pick up something we're already holding? Drop box. Get moon. I took a cardboard box. Why is it stopping at 8? That's what this is, isn't it? I took a cardboard box. So the get code is stopping at that particular thing. List 1012. Okay. If B string equals the right of A string, B string equals all of A string minus the first 4 characters, which is get and a space. So then we're doing a check. Does the code for the objects equal B string? If it does, then C% equals T. If object position of C% equals -1, then I was already holding that. So it's doing it in that bit. We're not changing C%. But it doesn't fit. Red resistor isn't the same as cardboard box. It wouldn't have the same code. I'm not sure what's going on. It's definitely saying, it's definitely interacting with the cardboard box, which is object number 8, isn't it? Object number 8. So, since I can't work out why it's doing that, let's move to a different room. Let's go north from where we are. There's the box on the floor. If we go north, get red resistor. I could not see a red resistor. Get moon. Could not see a moon. If I go south, in this particular room, get moon. I could not see a moon. Get box. Get red resistor. I could not see a red resistor. Get red resistor from box. Syntax error. Well, that's progress. I don't know why it's now doing something different, but it's progress. Okay. Get red resistor. Could not see a red resistor. Get red resistor from box. Unexpected next in 9100. Okay, now it seems to be doing something different, and I haven't changed the code. So, oh dear. Sometimes I despair. Run. Load. Test. Loaded. Okay, right. Also see a cardboard box. Get red resistor. It's 9:30 already. And we haven't got to the puzzle that I want to implement, which requires these resistors to be able to get out of the box. Get red resistor from box. I took a red... Why is it now working? Exam box. Now it's got the blue one as the first one instead of the red. A red 1000 ohm resistor. We have done it. Finally, we've done it. Pen 3. Thank you for returning, Patrick. I have no idea why this works. It's like that line. It's like that comic I saw one time. And it's just two pictures that are exactly the same of a frustrated coder. In the first one it says, my code doesn't work. I don't know why. In the second frame it's, my code works. I don't know why. I do not know why this didn't work and now does when I haven't changed anything. I'm glad it does, because we've got to get moving, but we have to change a spelling mistake first, because when we took the red resistor from the box, it said, I took red resistor, but it should say, I took a red resistor, or the. So if we list 9050 to 10,000, where is it? I took, right, edit 9090, so I took the space. Okay. Save episode 1. Okay. 9110. Oh, hang on. Save on the hard drive instead of just in the CPC mode. I mean, RAM. So, okay, 9500. Yep, that's fine. RAM extra drop code. List 9002 9100. Yeah, that's okay. Edit 9500. We need extra put code now. Extra put code. 9510 if d string equals left string equals left string of b string length of b string minus 9, because that's what we okay, that should 9520. We're just doing quick code to put the thing back into the thing. If for t equals 1 to object %, which is the number of objects, that is correct, isn't it? Quick check on my lists. Object, yes. To object 9530. If just checking some people out. Nope, they're just going past. Okay, that's fine. If object string of t, 1 equals d string, and then if objpos % of t equals current room % or objpos % of t equals -1, then objpos % of t equals -9, print. I put the plus object % t, 1 in the cardboard box, else. That will not work. 9535. Copy all of that into 9535, otherwise this will not work. Edit 9530. No, actually, no, let's just make this 9530. I'll just take all of that there. Go to 9535, else. Go to 9540. Print. I could not see a plus lower string b string plus full stop. Go to 3180, which is the code to jump back to the game loop. Yes. Hit 9535. Hi, Old Style Gaming, and yeah, I'm sorry I didn't win the election as well, but what can you do? Go to 3180. It's just how it is. You win some, you lose some. I'll move on. I have to. Right, I think that's enough for the put code, but we have to actually access that from the put code. So list 10800 to 11099. Yeah. Okay. Yeah. Patrick says, you're still our counsellor for the Amstrad CPC. Oh, thank you very much. I don't think that comes with a title, though, or a paycheck, but never mind, we can't have everything. 1011051. If, right string, B string, comma, length, no. Six equals in box, then go to, what was that we just did? 9500 else. List 9500. Yes, it is the extra put code. Okay, list 9500 to 9550. Edit 9510 because we've got the wrong amount. In space BOX is 6, so it needs 7. Okay. Nine 534. If t greater than 9 and t less than 15, then go to 9535 else. Print that would not fit in the box. Go to 3180 because I've just realised how we can put everything in the box, which we don't want to be able to do. Edit 9530 9534. Okay, I think we're okay now. Edit 9510 pen 3, just to make sure it's the right colour. Save episode 1. Patrick says he's doing a video of it as well, although we'll have to add a disclaimer that I've been involved throughout its development. You have, because if you're reviewing a game that you've been this intimately involved with, for example, you've seen it being developed, you can't be as objective. That's just how it is. Okay, I think we've now got the ability to put objects in the box. Run. Load. Let's do a quick test. Okay, we're in the room with the cardboard box. Yes. Inventory, what we got? Put crowbar in box. I'm sorry I didn't understand that. Put I'm sorry I didn't understand that. Put the proper What is wrong here? I'm sorry I didn't understand. Oh, I see. If list 10810. We just found a major issue. Okay, 10811. Gotta change it. I just found a major issue where we can actually crash the game by saying put and then not having anything else. 10810. If b string does not equal that, go to 10811 else pen 3 print. Put what? Put what in what? Go to 3180. Save. We should probably do that with the get code as well. Where's the get code start? 107 1017. One zero one 81 for t equals 1 to obj percent. Okay, and it's 10180. If b string, then go to 10181 else pen 3 print. Get what? Go to 80. Where did I just type that? JJXB, where did I type the wrong thing? I don't see it. Oh no. Whoa. Yeah, I did. Load episode 1. You're quite right, I just see it. List 108109110. There isn't a 10910. That's okay. List 10810 to 10820. I'm glad you found that. One zero one 81. Right, we should be okay now. 10180. If b string go to 1018081 else print pen 3 print get what? Go to 3180. Okay. List 10800 to 10850. Oh, 840 is fine as well. And put code is very simple. 10811 I need to put all of this in again. I just need to make sure it's fine, basically. If B string okay, that should work and stop us crashing the game. I have a question. What is this game going to be called? Old Star Gaming, this is going to be called The Arbiter, Episode 1, because there will be more. The Arbiter, she's going to have lots of adventures. It's going to be a fun series. The next one, she's going to land on a planet of giants, and basically it's going to be like an episode of Land of the Giants. So that's going to be fun, and she's going to have to be able to sort out all kinds of weird situations where she's in a world where everything's far too big. So I think that'll be fun. Okay, we need to do the drop code as well, just to make sure that we don't crash the game by having nothing. We'll sort that out later. Run. Patrick says he's working on a loading screen. A loading screen for what, Patrick? File name test. Loaded. Put. Improper. Oh, this game needed especially for... Yeah, we will need it. I've actually got a loading screen in mind. I'll send you some information. Improper argument in 10810. If B string equals put or B string equals put space, then go to 3180 else. Can CPC do loading music? Technically it can, Old Star Gaming. There's a brilliant demo of that, in fact. Wasn't it called Breaking Board? It was at a demo... yeah, it was at a demo convention a few years ago, and it's an amazing thing. Right, put. Improper... Okay. We're going to end up crashing a lot at this rate. Edit 10810. I don't know what's wrong here. There's a take out of this out. Basically, if you just type put, it's going to break the game. And I can't be bothered working on why, because we have other things to do. Run. Let's just get back to this game. Let's see if our code is kind of working to be able to not put a crowbar into a small cardboard box. Put crowbar in box. I'm sorry I didn't understand that. Get resistor. Get red resistor from box. Took the red resistor from the cardboard box. Put red resistor in box. Sorry, I didn't understand that. Oh well. Well, we've got the red resistor out. Okay. I'm going to leave it there for a moment. I have to go and check something downstairs. I've just realised I may have left some lights on. I will be back as quickly as possible. I'm sorry about having to run off, guys, but we will go for a little bit longer. If you guys are fine with it, we'll go on past 10 o'clock. And we'll get this done. We'll get the next thing in. I'll be back in a moment. Okay, sorry about that, guys. I'd left a load of lights on downstairs and it just suddenly reminded me there. Okay, we have... I need to add in 3 more objects, which means that we need to save the test game again. So I'm going to make a quick note of this. Where did I put my pen? Why is it... There it is. Why is everything going wrong tonight? It's bank holiday weekend this weekend, isn't it, guys? Yeah. Cartsman says, go for a long stream. We'll still be here. Thank you very much. Okay. 15. Burned resistor. 16. Charge resistor. And 17. Fried resistor. We need to add those in. So, where does the objects begin? Object state starts at 2,500. Pen 3. Let's be able to see this just 500 to 3,000. Blah 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 blah. I say go for a big stream too, says Patrick, as long as it doesn't get you in trouble with Jen. Jen won't mind. She's up in the attic fiddling with weird train set, which you can see on her own channel, so I'd recommend that. She's got a mega train set up there that she's been making. So, 2534 data. Data is a burned resistor. Burned resistor. A burned resistor. That had been burned to a crisp and was now unusable. 2535 data. Charred resistor, a charred resistor. This was a resistor that was charred beyond recognition and certainly would not function anymore. 2526. Oh dear. I've just broken the game again. Load episode 1. Sorry guys. List 2530 to 3000. Gotta put that in again. 2534 data. Burned resistor. A burned resistor. This was a burnout. 2535 data. Charge resistor, a charred resistor. This resistor was charred beyond cognition and certainly would not function properly anymore. 2536 data. Fried resistor. Just need them all to have different names because we need to be able to distinguish between them when the commands are being used. Okay, fried resistor. This resistor was fried to the point that it had started to melt. It would no longer function. Okay, edit 2610, the data statements about where objects are. So the burned resistor can go in -10. The fried resistor can go in -11, and the charred resistor in -12 or whatever. I think actually fried will be in 12 and charred will be in 11, but never mind. Okay, save episode. No, because we need to set the objects list 1 to 10. Where is the object statement? Edit obj. Edit 6 even, because objects is now how many? It is now 17. Save episode 1. Okay, right. This should get us moving now. We should be able to actually do the game. So, what I've just done is I've put 3 extra objects, burnt, charred and fried resistors, into the slots in the inventory for our logic puzzle. The logic puzzle is basically the arbiter has to be able to get a resistance across a circuit of 464 ohms. Now, if you remember your physics classes from school, you'll know that any system that has resistors in parallel and in serial gets a little bit complicated, but the arbiter's multi-tool will tell the arbiter what the resistance across the circuit is. So, it's going to be a matter of either working it out using physics, which I already have done. I've got a page, in fact I'll show you, let's bring it up on the big screen, a page of notes about how to work this out. All of this. I've got the calculations already worked out, so we're going to be able to put in a code where we can calculate the ohmage across the circuit. And that's a good thing, because we need to be able to function. So, let's do this. Where can we put it? Where in the code can we put it? From 12,000. Oh, hang on. Let's go back to the screen. Yeah. List 12,000 to 13,000. Right. 12100. Rem. Print circuit on screen 12110. Pen, let's say pen 2. Old style gaming says, OSG says, haha, at last something I understand. I have a degree in electrical engineering. Well, I don't have a degree in electrical engineering. My degree is in particle and nuclear physics. I hope that I've got these circuits right and that the resistance will be calculated correctly. I have a feeling I have, but I'm basing this on A-level physics that I last studied in 1999. So, a little bit old, but I'm going to hope that's right. Is there any of this? Time for some Coke, I think. So, we're going to print a circuit on the screen. We're going to print a circuit on the screen, and hopefully it will look okay when I do it. Do this. Right. Print. I'm gonna. Yeah, print. I'm just gonna print a load of stuff on the screen. Run 12110. Yeah, that works. That's okay. No, it isn't. Edit 1 12110 because I want a few spaces. 2, 3, 4. 1, 2, 3, 4. 2, 1, 1, 0. Print. Bar. No bar. Where's the bar gone? There it is. 1, 2, 3. Space. Space. Run 1. Oh, for goodness sake. 1, 2, 1, 2, 0. I'm making a lot of mistakes tonight, and I really don't know why this is happening. Because sorry guys, we end up having to do an awful lot of this again, which is not great. Okay, print down screen. No! Run 1, 2, 1, 1, 0. Yeah. We're getting somewhere now. Edit 1, 2, 1, 2, 0. That's too big. 1, 2, 1, 3, 0. Plus, if RA equals 0, then print else print RA. One, 2, 1, 4, 0. Yeah, that should work. Print bar. Edit 1, 2, 1, 2, 0. I'm trying to set up a realistic looking thing here, and it's 2, 3, 4, 5, 6. 1, 2, 1, 1, 0. I'm trying to set up a diagram to make it look acceptable on the screen. Yeah, that works. Okay, we're getting somewhere now. 1, 2, 1, 5, 0, print. Is there a character for an ohm in the in the list of characters? Because I can't remember. I genuinely cannot remember. I think there is. I think there is an ORM because a lot of the Greek alphabet's in. Yes, there is. Character string 191. Well, that's not right, is it? There are some slight graphics on the basic CPC font which would make the diagram look better. There are some graphics on the basic CPC font that would make the diagram look better. You're right, Patrick. Maybe we'll use them at some point. We've got something wrong here. Yeah. Because I just put that in the wrong place. That's not what I want, is it? List 1, 2, 1, 1, 0, 2, 1, 3, 0, 0, 0. Let's have a look. Blah, 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 blah. Edit 1, 2, 1, 4, 0. Print. Character string 191 plus edit 1, 2, 1, 2, 0. Add in an extra bar. Run 1, 2, 1, 1, 0. Also, if you do a numbers, print character string 191 and copy the omega symbol direct onto the line, it might help. No, it's not, because I need to do something else. My problem is I need to make this look a certain way. I haven't done that. Edits, no. One, 2, 1, 4, 1. Run 1, 2, 1, 1, 0. Now we're getting kind of there because I need some extra things in. 1, 2, 1, 4, 2. Print. Yeah. 1, 2, 1, 4, 2. This is getting a bit weird, but we're getting there. Run 1, 2, 1, 1, 0. Now we're getting somewhere with the circuit. Actually, we are getting somewhere with the circuit. Wow, that's looking slightly less awful than it was before. Yeah. We're getting there. Right, we're getting there with the circuit. That's good. That's good news. Edit 12143 because we need to. To 152. Plus character string 191 plus okay, let's see if that works. No. Run 12110. How's that look now? Now we're getting somewhere with this. We are getting better at it. Yeah, this is coming together. 12110 plus 12110 to 13,000. For goodness sake. Okay. What's the bit with B? What is it saying B? There. Edit 12142 because that's not B, that's C. Edit 12143, which needs 2 extra dashes just here and 2 fewer of those. Run 12110. Now we're getting somewhere. Yeah. 12143. Just that bit there. That's not it. Edit 12142. Lines into A need an extra dash. Yes, you are correct. Edit 1214150, isn't it? Yes. Dash dash bar run 12110. This is getting weird now, isn't it? Right. Now we're getting somewhere because that's not wrong, but it's not quite right either. Edit 12144. Edit 12143. Run 12110. This is going to make an awful lot more sense once it's all dealt with properly. Now we're getting somewhere because this looks right almost. Almost. It's not quite right, but it's almost. Edit 12141. Just this. So now we put this bar in there. Edit 12142. Okay. That should be a plus. 1, 2, 3. Plus 1, 2, 3. Run 12110. Now we're almost there. Almost there. Edit 12141. Just this bit here, which has an extra space there. Run 12110. We're almost right. Yeah. Edit 12120. No, that is not right. That's that bit there. Edit 12110. Right, so it's 1, 2, 3, 4. Yeah, now we're looking right. Edit 12120. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 in a bar. Run 12110. Getting there. Can you see what I'm getting at now? One, 2, 1, 1, 0. We're starting to get the circuit diagram together, and it's almost there. Not what I was looking for, but okay, because that's that bit there plus plus 1, 2, 3, 4, 5, 6. Run 12110. Run 12110. Yes. Now we're getting somewhere. mean it's wrong, but we're getting somewhere. And 1, 2, 1, 4, 2. This should be right. 1. Then, oh, for goodness sake. That should be like that. Run 1, 2, 1, 1, 0. Yes, any polishing on the characters can be done once I've got it right, but I've got to get it in right in my head. 1, 2, 1, 4, 1. That's not right. Now we're getting somewhere. Edit 1, 2, 1, 4, 0. Just. Which bit's this? Where did I just put that? There it is. So it's not that. The advantage in using the advanced characters in the CPC character set is that you can join the lines together. You are very true right there, Patrick, but right now what I need to concentrate on is getting this correct. I'm missing a line, so let's just list 1, 2, 1, 1, 0, 2, 1, 3, 0, 0, 0. Where is it? Where is it? There it is. Edit 1, 2, 1, 4, 3. Because that needs to be a line there. Bar. Run 1, 2, 1, 1, 0. Sorry if that got boring, guys. I needed to fix that. That's all I needed. Oh, there we are. Now we're getting somewhere. Lines under C needing a bar. Probably. Right. Now we can move on with the rest. So list 1, 2, 1, 1, 0, 2, 1, 3, 0, 0, 0. Oh, for goodness sake. Right. 1, 2, 1, 6, 0. 2, 1, 6, 0. We're getting somewhere now. This is working out. Edit. Yeah, I see where you're talking about the bar. Yes, we do need that, Patrick. edit 12143 space and bar, run 12110, 12110. So now we're getting somewhere. So run 12100. So 12170 print. Copy the rest of that up to that. Okay, 12180. One, 2, 2, 0, 0. Run 12100. We're getting there now. We're definitely getting there. We've almost got it. Yes, that is looking good. Yes. Now we are getting somewhere. 12190 print. The things we do, for what we enjoy. Bar. B. If RB equals 0, then print one, 2, 3, 4 plus else print RB. No. That print RB, comma, semicolon even. Yes. 12195 print no, run 12100. See how far we're looking through this? We've got to that. Right. 12195 print character string 191 plus, so we're there, space bar space plus 1, 2, 3 plus 120 plus character string 191 plus 1, 2, so we're here plus 1, 2, 120 ohms, 1, 2, 3, 4 bar space bar. Run 12100. Edit 12190. Should be a plus. Should be a bar, and that should be a bar. Run 12100. We're going to get there in a moment, guys. This is just a bit faffy, basically. Edit 12190. Shouldn't be a space there. Edit 12180. Bar. Edit 12170. Bar. Run 12110. Is this a circuit? Very close to it. Very close to it, but it's not quite right. Because that, you know, that outer bit where I've put all those lines, shouldn't be there. For most of it anyway. List 12100213000. Oh, for goodness sake. Yeah. Okay. Edit 121120. Edit 12130. We're getting somewhere now. We are definitely getting somewhere because that doesn't need to be there either. Doesn't have to be right now, no, but it does have to be an accurate circuit diagram, otherwise it's going to look weird. Edits 12150. Now we're getting somewhere, because this is starting to look like the circuit diagram that I want. Edit 12141, because that shouldn't be there. And that one shouldn't be there. Run 12110. edit 12142. Almost done, guys. Edit 12143. 12110. Okay, what we have now is the circuit diagram. The extra bar that's just above the Y on the ready prompt, we can take that off later. That is the circuit diagram. List 12100 to 13000. Okay. List 12110 to 12150. Okay. We need to set the RAs. So 12115. Okay. If RA equals 0, RB equals 0, RC equals 0, 12116. If POS yes, so if OBJPS of 9 equals minus 10, then RA equals 1000. If OBJPOS 10 equals minus 10, then RA it's going well, Jen, on this live stream. Then RA equals 1000. If OBJ POS, and all of these need a percentage of them, JPOS percent of 11. Oh, that's 10. Or J possession minus 10. 9, 10, or 11. Or OBJPOS 11 equals minus 10, then RA equals 1000. 12116. Minus 11, is it? Yes for B. One, 2, 1, 1, 8. Jen, no, I don't want ice cream. Thank you for asking. 12, 12, and 12. Okay, now we're getting somewhere. 12. 1, 2, 1, 1, 9. If we need 12 in all of these, then 10, then RA equals, if this is something to 12552, if 12 equals minus 11, then RB equals 552 if of 12 is minus 12, then RC equals 552 to 111. Let's set all of those to that. 12112. What I'm doing now is setting up all of the little bits that we need to do to set the variable ohmage of each of the objects. 601. Is 601. One, 2, 1, 1, 3. This is the last one, isn't it? 14. Yes, it is. Almost there with this little bit here. That's 407. 414. List 1211021300. Right, we're now getting they should probably have a rotor for bandwidth for streaming. Who should? Have you been streaming while Zoe has been too? Can't. Is there something wrong with the Sorry guys, is there something wrong with the stream? Is it breaking up? Is that why people are asking about the streaming? Jen will probably be looking at it upstairs, yes. Okay, 12210 print. If OBJPOS of 1 equals current room percentage or OBJPOS I guess you and Jen have a rotor for streaming, so you're not streaming at the same time. Yes, we do. Jen will be live streaming tomorrow. I stream tonight equals -1. Then go to 12220, else go to 3180. 12220. Okay, now we're certain. Now that that's done, we need to find the amperage, not the amperage, the resistance. So, R1 equals RA times 1000. R1 equals R1 divided by equals RA times 1000 divided by RA plus 1000. RA R1 equals R1 plus RC. 1 2 2 2 2 2 3 0. Yes, that's the whole of that top row. R2 equals RB plus 120. RT equals R1 times R2 divided by R1 plus R2. 2240 print. According to my multimeter, the current resistance across the circuit was plus RT ohms. Go to 3180. Save episode 1. Right. Godsman says that he's just taking a look at Jen's channel and there's some awesome looking tracks. Yes, they are. She has done really well. Okay, we have just set the stuff about the circuit, and yeah, print circuit on screen. 1 2 1. Right, so now we need to look at the examine code. 10080 list 10080 to 10120. So 106. If B string equals circuit and current room percent equals what is the room of the computer room, blah 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 blah, 4, then go to 12100. Save episode 1. Drives, not save. Run. Right, we should now have the ability to examine a circuit in the computer room, but it probably doesn't tell us that there's a circuit in the computer room yet because we haven't put that in. End of file met 11250. We haven't changed any flags. And I've just... Sorry, guys. I've got to go and wash my hands. I've just touched a cold sore. That's really not a good thing. Sorry, guys. Back in a sec. It's going well, but I've got an interesting end of file I'm not sure about. Right, I think I know why this is happening, so let's run it again and we'll start the game. And if it doesn't happen, then I know where it is. Start the game with S. Yeah, the reason for the end of file was because we've added in extra objects and then didn't add them into the save file. So let's go down, get multi-tool, get core, up, east, out, southwest, search wreckage, west, west, use crowbar on hatch, west, use multi-tool on wires, because we forgot to do that, use multi-tool on wires, west, down, get junk, put core in housing, thump, because the thing's gone off, oops, north into the computer room, okay, exam, circuit, type mismatch, edit 1224, I should have saved before we did that. Oh, we can't. Right, I see. Print RT, print ohms. That should work. Save episode 1. OSG saying you've got to go. Right, see you later, OSG. Thanks for coming along. You're saying you're in awe of the coding skills. Well, there aren't many skills coming out on display when the fact is we keep breaking everything, but we're getting there. Right. Let's save once we've set everything up. Start the game. We're not adding in any extra objects at the moment, so down, get multi-tool, get core, up, east. Yeah, basic is a dying art, OSG, that's very true. Search wreckage. But it shouldn't be. Basic is a great language to learn, and it really gets you started. Use multi-tool on wires. It gets you started. It gets you understanding things. What is it these days? I can't even remember what it's called. Scribbler or Script or something like that. Something like that. That's what kids are into these days. And to be honest with you, I'll try it out at some point. I know that one of the Alpha twins demonstrated to his son that he could write a program in, was it Scratch, I think it's called? In Scratch overnight by making a basic Dizzy game. That was cool. Python's alright, OSG. It's not bad. It's not the best, but it's alright. Get junk, drop junk, put core in housing, thump because the doors are open. Okay, save, test. Right, that's saved. North. Okay. Exam circuit. According to my multimeter, the current resistance across the circuit was 0 ohms. There we go. We're now getting somewhere. So now we can see the circuit. We can't do anything with it. Right. I think now is the time to stop because we've just spent ages getting that in. The next episode will finish off this puzzle. Well, actually, while here, we'll make a few cosmetic changes to it, but we've got the main thing. Next time we'll be using the get and put commands to put things into the circuit. But let's tidy this up with the circuit. List 12100 to 13000, and just get rid of all the extraneous bits and pieces with all the extras. Right. Edit 12150. 60. All these extraneous extras. Edit 12170. Edit 12180. Save episode 1. List 12110 to 13000. How are we doing with this? Where do we get the start? Right. Run 12120. Edit 12200. Run 12120. Yeah, now the circuit's looking correct. Kind of. That's 12120 to 12200. Where was the bit by C? Yeah, it's working now, so we're doing okay. 12200 to 13000. Blah 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 blah. Where's the bit? Edit 12240. Run 12240. Yeah, now it works. We're doing okay. So if we save episode 1. File, drives, df0, save. Right, guys. That's been a long one. We've gone an hour over, and we've got some good work done. I think we're getting somewhere with this now. This is going to be the complex logic puzzle that pretty much... it's going to be the bit that people get stumped on. They've got a reasonable game to fiddle around with, and then this will be the bit that stumps people before they move on to the next section. I want 2 of these type of stumper puzzles to make the game have a bit of meat to it. So it's not just use X on Y all the way through to get through it. So it's going well. We've got a fair way into it. Next week we'll sort out the way of getting things in and out of the circuit, and making the circuit work and putting the actual physics to use. Once we've done that, that's going to be the big thing. So, as usual, I will now sort out making a copy of this version of the file available to you. So, wait a moment and compress this down. Compress arbiter1.dsk. We are getting a long way into this game now. I'm really enjoying this. I hope you guys are as well. Where is it? Arbiter game. There it is. Where is it? Zip. Episode 6K. That is uploading onto my Dropbox now, so copy the link. Wow, it's taken a while to upload it. Don't know why, but that's pretty strange. There it is. Right, I'm going to put the link into the chat now. Arbiter 1 episode 6, and as usual, I will make this available on the GameHammer channel in about 5-6 minutes, where it will also be playable. Because yes, it is now possible to play games from GameHammer, and I'll show you that. Bring this back up. Here's the GameHammer website. If I go to this one here, it's a new link on the website, gamehammer.co.uk, where it says play our games. I press that. Well, when it loads up, my goodness, everything's slow tonight. I hope the live stream's working out. Then it will bring up a couple of games. I think Arbiter episode 5 is there at the moment. Yeah, the Arbiter episode 1, as it stood at the end of episode 5. If you click on that, it will load Java CPC and run the program for you. So that's going to be something that you can do now. If you don't want to faff about downloading the file and loading it into your emulator or loading it onto your CPC itself, then that's a possibility now. You could play online. It's not going to work while I'm here. Never mind. But that's the idea. It's going to be something that we can do from now on, and I hope that you've enjoyed that. And I hope that if you give it a try, you can enjoy that too. The other game that I made, The Quest for the CPC and Disc of Power, is also playable via the website now, which is nice. And speaking of CPC, I am editing the latest episode, episode 8. We'll be getting back into the swing of things now that I'm not spending all my time doing elections or casework for my council work, because I'm no longer a councillor. I'm self-employed again now. Full-time self-employed, so we'll see how it goes from there. And right, that's everything. I think that's everything. I hope you've enjoyed this. It has been a bit weird because I'm always wary when doing this coding that sometimes it really just slows and grinds to a halt essentially with the game progress. Sometimes that's going to happen. We're going to get through this game. We've done 6 episodes now. I hope we don't need that many more to get through the bulk of the game. So, thank you very much for watching. I hope you did like this. If you did, remember to click that like button and share it with people so that they'll see how this game is coming together. And I will see you next time, same channel, next week. Thank you very much for watching. It's really been appreciated. See you next time. Bye.